Cool. Okay to start? Yeah, awesome. Hi, everyone. Yeah, I'm Matt. I will just run through a quick intro. For anyone who doesn't know, this is our lovely, cute little friend, Hot Chip. We'll see more of them later. Cool. So I'd like to talk to you about building a cloud-native bank. I work at Monzo. In kind of more Monzo-y fashion, I guess this is more of the kind of talk title. We love emojis. Yeah, as a quick intro, I'm Matt. I used to work at Halo. I worked on our platform team. We built kind of a distributed system that ran across multiple AWS regions, where I met Abby. And we had many adventures together. And if you have any questions, either grab me after. I'll be around all evening. Otherwise, ping me on Twitter. But yeah, for this talk, I'd like to talk a little bit about banking, which is normally like super boring, right? Who has had a fun experience with their bank? There's one person who works at a bank. Banking is kind of like this, really. This is kind of the impression I have of banking. It's not really changed. You kind of have to go to branches here and there. Sometimes you go to a branch and you have to sit down in the branch because you can't speak to someone there. You then have to pick up a phone in the branch and speak to someone else. I don't understand. Some people have crazy starry eyes. It's a terrible experience. So at Monzo, we want to make that a bit better. We want to help people manage their money better and really kind of give people control easily in a modern way through your phone, which is kind of the thing you'd expect in 2018. When, I don't know, like I can get a taxi to roll up here with probably food inside it in like the space of 2 minutes, but like I can't see my balance up to date for like 48 hours sometimes with a traditional bank. Anyway, you might have seen some of our debit cards around. We have these luminous, they glow under UV light, neon debit cards. So we kind of launched these a little while back, and over time we've grown quite quickly. Turns out when you grow 5% a week, that's quite painful at times. I would not advise it, but it's super exciting. As of a week or so ago, we have more than 1 million customers. Overnight, that changed by, I don't know, 5,000 or 6,000. I had to update the slides. And so far, we've had about £4 billion spent through our cards. So yeah, to give you a quick rundown, we're a bank. We're regulated by the FCA and PRA. We have all the normal guarantees and protections you'd have if you put your money in HSBC or Lloyds or whatever, but we have a much better app. You can use Apple Pay, normal, and Android Pay, not Samsung Pay though. Does anyone use that? No, good. So we have like the normal kind of banking features that you'd expect. We also give people real-time insight into their money. So, for example, if you go and shop at Burger Bear, which is a burger place up at Old Street Roundabout, one of the few places you will get 2 emoji at the beginning, a burger and a bear. But ultimately, we're doing this so that you can see like where you're spending your money, and it gives you a far more tangible grasp on like how you spent your money. Like spending money on a card is like really kind of opaque. You don't have cash that sometime later you don't have any. It's like this kind of ephemeral number that is somewhere further away. So giving people like that insight into how their finances work is kind of the core of what we are. So yeah, you can send things to nearby people. You can see how your money's being spent. For 3D Secure, like we've built this a few months ago, and the team worked on it amazing. Normally you have to remember some like really cryptic password and like answer like 3 characters. Cool, so we send you a push notification and you approve it on your phone, and then it magically works. And like we show you who the merchant is, and we put their logo there. If you want to connect your banking app to a myriad of different services, we're integrated with the if this then that. So every time you spend money at McDonald's, we can put money into like a fitness fund. And anytime you go and spend money at a gym, we can take money out. Loads of people have done stuff like that. Is really cool things that people have done. And the other stuff is slightly more kind of the things that we're a lot more interested in, things where we can like genuinely help people with their lives. So one of the things that we released more recently is the ability to block gambling transactions. And you can block this by tapping a button in the app. And then your card just doesn't work on gambling websites. And you can turn it back on any time, but you have to speak to us to turn it back on, and it takes 48 hours to turn it back on. And that amount of friction massively reduces the impact that gambling has on people who kind of identify as heavy gamblers. And those are the things that we want to help people with. So yeah, we're used all over the world. You can't really see that slide that much. This is the data from a day in August. We did like 1 million transactions a day or so. But ultimately, all of that comes back to we wanted to help people manage their money better. And in the UK, the best way to do that is to become regulated as a bank, which is cool, except how does one build a bank? Day one, you open, let's say Atom, open your text editor. Cool. Panic intensely, and then realize that getting a banking license takes a really long time. So we kind of went through this process starting in February 2015, and it turns out that on day one, you can't just take people's money, obviously. You can't just hold it for them. You have to go through good regulation processes to make sure that you are responsible and comply with all the kind of basically common sense stuff that you really should do if you're in a position of responsibility. So in our case, I don't know if anyone's seen this, this drawing by Henrik Nyberg. If you want to build a product, iteratively, we could have gone this top route. We basically got a year and a half where we can't give anyone a product. So we could have sat in our office and built what we thought a good idea of a bank would be. And then once we finally got our banking license, then we'd release it to people and kind of really pray that we got it right. Whereas if we go through that in a kind of, I hate to say it, a more agile kind of iterative way, we can hopefully get something that customers actually want, rather than kind of guessing at it, making the wrong assumptions and getting it all wrong. So on day one, we couldn't really do much. We don't have the ability to hold anyone's money, so it's kind of a really good question. Obviously, we want to run this in the cloud somewhere. We want to run it on Amazon. Myself and a couple of other people have experience with Amazon. It's kind of a natural thing. Problem is, it's 2015, so the FCA hasn't issued their cloud guidance that allows you to do that as a bank. So it's very unclear if we would be able to do that. So it's a very stormy kind of cloudy time here. And we really thought we might have to run either on-premise or on some other co-located servers. But we're building a prototype, so for the moment, we can just build it on Amazon, and we'll kind of pray that it all turns out in the end, which thankfully it did. So the FCA released guidance on that, kind of guidance on how regulated industries should use public clouds. There's been an update of that, I think, this year, and that kind of has changed the regulated industry now, so you can actually use Amazon and Google as a regulated bank for your core banking infrastructure. We don't run any applications outside of Amazon. So if you bank with Monzo, all of your money is in Amazon right now. And it's really secure, and it's super reliable as a result. But that's the thing now. It's cool. So to go back to our thing, we need to build a skateboard, step one. We don't have the ability to hold anyone's money. So we'll start off with 3 very hungry employees. I'm really hungry. And being bankers, we're going to go out and get some lobster to eat. For those of you who don't know, the lobster emoji is in Unicode 11. It will be out in iOS 12.1 in a couple of weeks, so quick preview there. So we don't have the ability to do that. You'd pay in a restaurant. We can't do that. So instead, one of us will pay, and we'll have money that we will exchange in a closed system. So that is cool because we can pay each other, someone else can buy some coffees, we can send money that way. And we can build this prototype with a sealed system. We can build it in Amazon, and we don't have to integrate with any other things, but it allows us to build our product, build an app, and we can test it with customers. So at this point, we're kind of aiming for these 5 things. We want the system to be extensible, because as soon as we need to build it quickly, we're going to have to integrate with a lot of payment systems, and they will vary wildly. Some will use IBM MQ to connect. Others will be SOAP. SOAP is kind of the pinnacle of technology in banking. So we know that we will have to integrate with these systems, so keeping these as self-contained walled things would be really useful. It needs to be scalable. Hopefully we'll grow really quick. It needs to be reliable. It's people's money. It needs to be secure. It's people's money. And ultimately, we're a startup, so we're skinned, so it needs to be cheap. So in our case, we would traditionally start with an application. We want to build a couple of small applications to do this, to avoid the kind of inevitable feature bloat that you would get over time. So kind of everyone does this these days. You build a set of microservices, and then, I don't know, you have a party, and it's like this wonderful land of rainbows. But it's really not. It's really complicated, and you have a lot of moving parts, and some of them might be asynchronous and some synchronous. Some might be on fire. Who knows? It's the Wild West. So at this point, we can build a prototype. We kind of get to about November 2015. We've been exchanging debt and buying each other's lunch and moving money around. I'm pretty sure that Tom, our CEO, just kept that money in his back pocket for a really long time. Probably shouldn't record that. But at this point, we finally got the ability to get some cards. So we partnered with a prepaid debit card company. They allowed us to integrate their cards. Essentially, we provided a SOAP API that they called in real time within the authorization period. So we had the ability to decline transactions at the machine based on our own internal logic. And that was really cool. I mean, we use Go, and Go is terrible at XML. So there was some pretty sketchy parsing there. But it all worked, and we could get money out, we could spend cards, and we could integrate that into our systems. So you kind of see how we're slowly building up these chunks of different systems, and keeping them isolated from each other is really useful for us. So yeah, Hotchip rocks up. We're kind of at this point, so we're a very long way from the point that we get a banking license. But we can issue cards, and we're holding the money under another company's banking license. We're operating under those regulations. We can build out our app, and the microservices start exploding. So this is scrawling on a whiteboard paper, I think, in my bedroom at some point in April 2016. So this is kind of showing how we have some flow that's coming into the system, and we have a lot of other stuff and kind of an app over there. And please don't look too much at this. Only some of it still exists. But even at this point in April 2016, these individual services are very simple and easy to understand, but there's a lot of moving parts. And over time, that has increased quite a lot. So we have I don't know, 720, 30 services now. 99% of them are written in Go. We have a couple in Java and Scala. And these are all running in Kubernetes in Amazon, which I'll come on to in a minute. So to go back to this point, we have our phone. We need to connect it to some form of infrastructure. We've written a number of small applications that are essentially a HTTP server and a really basic set of functionality. But to actually connect that all up, who knows? So we start off in Amazon. We have an EC2 instance. I'm pretty sure we didn't create them manually to start with, but it's a very long time ago, so who knows? And I think at this point we created really basic infrastructure, and we had a couple of auto-scaling groups, a VPN so we could get into our thing, and then we could deploy the code onto that. And we actually used Mesos originally, again because we might have to move on to physical infrastructure, and that had that abstraction layer. Mesos was terrible. The marathon scheduler, when it was version 0.7, which we were using, is much, much better now, probably really reliable. But the version we used lost the cluster state repeatedly. It lost the fact we were running any applications. Our applications were shut down. That would not be ideal. So obviously when that happens, no one's cards work, which is a problem. So in order to kind of be able to scale this out and be able to run multiple versions of each application, we end up with a number of instances. In our case, we're running this as auto-scaling groups across each availability zone within EUS1. We'll expand to multiple regions probably either this year or early next year. And on top of that, we run Kubernetes. So who here's either heard of or who's used Kubernetes here? Yeah, OK, quite a few people. Cool. So Kubernetes, we essentially run on top of our EC2 instances and kind of assimilate these by running a kubelet on each one. They're going to talk to the Kubernetes master, which will decide which application will run on each host. And they're backed by etcd. So etcd really is the kind of the linchpin in the entire application. If our etcd cluster stops working for any reason, nothing can be scheduled. Like, no changes will happen. The applications will stay running on these servers, but if those servers go away, they won't be started on other ones. So it's of critical importance that our etcd cluster is working. And this is something that if you choose to run Kubernetes on your own, as Abby has discussed many times, this is a lot of work. Like, it's a huge amount of work. And if you can outsource this to Amazon or anyone else, you should definitely do that. In order to keep etcd alive, we could run one server. That would clearly be a very bad idea. Although there's interesting things. If you were obtaining locks and it went away, I mean, nothing could get a lock. So when it came back, everything would get a lock and it would be OK. But your cards and everything wouldn't work for that duration. So in our case, we need the state to remain persistent. We could run 3 copies, 1 in each availability zone. The problem there is, like, if we lose an availability zone or there's a partition between those, we're in a kind of worrying state where, like, a single node failure, a single process failure could stop our entire bank working. That would be bad. So we run 9 of them, which is kind of like the highest recommended number in an etcd cluster, because you have a single master that is elected. And there's a lot of work that's going on between these nodes. In order for this to remain working, we need a majority quorum, so we need 5 nodes, which means we can lose an entire availability zone and our application keeps working. Quorum's good, all good. The reason we use 9 is so we can also lose another node in a different availability zone, or say we were, like, cycling this node and it was down, and we had a network partition, like, again, we're still good. So in this situation, they'll all go away. Hopefully they'll come back. And once they do, we have quorum and we're good. So in our case, the way that we do this is we use Terraform to manage this infrastructure. For each one of our etcd clusters, we actually define 9 auto-scaling groups of 1, which are EBS-backed and have the data on a specific, like, named EBS volume. And that means that because they have a fixed identity, we have a really small program on this that when the server starts up, it will reattach the correct volume, and then it launches. And that means we're not ever dealing with cluster changes. So if you have an etcd cluster, you need an active cluster to vote on a new member joining. So if your cluster is entirely down, you can't change the cluster membership. So this solves that problem, because if we delete all of the servers, they all come back up later. They all still have the same node identities. There's no voting that happens. It all works. We've tested this. We can terminate the entire cluster. We get a working cluster within 2 minutes, which is nice. So in this situation, if we lose 5 of them, we only have 4. We've lost quorum. Our etcd cluster is essentially offline. They all go away. Our auto-scaling groups will then start the new instances. They come back up, and we're good. So if that's something that's interesting to you, we've got a blog post on this with some sample code and I think a CloudFormation template that will kind of give you a basic version of that. That's on our blog at monzo.com. So to go all the way back, we have a Kubernetes cluster, yay, that is a really small amount of work to keep running. And then on top of that, we can run a number of pods. And in our case, a pod can have a number of containers inside. Most of ours are a single container because we're running a single service. And in this case, it's a Go service. The Go runtime is compiled. It's in the same binary. It's a single file. So we can actually use a Scratch container. There's not even a shell inside these containers, which is really nice. Like, a lot more secure than having, like, a full Linux distribution with, like, I don't know, 5 trillion Ruby files or something. So that's quite nice. And we can use ECR to deploy these, and we're good. So in our case, we have a load of services. If we're running 3 instances of a particular service, one of them fails, or the entire node fails, we will get a replacement, and then Kubernetes will migrate those work tools across. So that's cool. That means if, like, our banking ledger, which runs inside Kubernetes, has, like, there are a number of machines that fail, the ledger will automatically migrate to a working set of machines. And we run, like, almost everything inside Kubernetes. So as I said, we have like 700 plus Go services, a load of Java ones. Each one of those we're running between 3 and, I don't know, like a couple of hundred instances of. We also run a number of Elasticsearch clusters, Kafka clusters as stateful sets. We use Calico for networking, so there's like a load of components there. We run Prometheus, Grafana, Thanos, all of our monitoring systems, and various other components. Pretty much the only things that we don't run in Kubernetes are our Cassandra clusters currently. Running databases is like a strong step. So we tested that with like some of the other systems. We've been running Kubernetes in production for more than 2 years now, and we've been running Kafka in production for more than a year, and we're very, very happy with how that works and works on top of Amazon. So realistically, we'll move some of our Cassandra clusters into this cluster at some point, probably next year, maybe this year. And it's been a massive cost saving for us. So this is kind of 2 years ago, our kind of costs dropped massively because we could more densely pack our applications into those nodes. Cool. So everything's happy. We run everything on Kubernetes. The world is great. Except sometimes it's really not. So we've had loads of problems, some quite interesting. So every pod that you run in Kubernetes, you can define resource constraints. That's really good because you can stop things going completely haywire. So you usually define like a request level and a limit. So as we can see on this, actually, like there's a lot of stuff that is bumping around the request. What that would mean is if you have 4 CPUs and you have 4 processors that request 1 CPU, it's kind of like, yeah, I probably need that, but like probably not much more, unless I'm bursting. Then that should nicely pack them onto your cluster, and you'll get like pretty good utilization. Sometimes things need a lot more. So this is actually us running a load test. And this is Linkerd, one of our, basically our proxy that goes between services. So we can see here that it's massively spiking up. And during this time, that makes requests slow. So dealing with that and dealing with the amount of CPU throttling that we have has required quite a lot of tuning. And we can see here that some of these are like really heavily throttled. So they're just very, very slow as a result. So tuning our Go processes has been like a really kind of interesting and time-consuming thing to do. So on that, we kind of have a number of other patterns that we use to make systems reliable, which I'll quickly zoom through. So we have a kind of big soup of stuff, right? Like, we have no way to get to it. So we have something on the internet, a phone. We need to go to an API of some form. Rather than having one massive API, we've split that into like a kind of API gateway pattern. So you can use Amazon's API gateway to do this, and then route individual paths through to specific deployments on a variety of different things. In our case, this is taking that, doing like a load of like kind of internal stuff, and then routing that onto a number of API services. So we have a public API. If you're an account information service provider, you can access, well, people can give you access to their banking data, and you can do interesting things. If that's you, come and see me after. If you're just an individual, you can access your own data through this. And each one of these sections of the API is a different service. So that's cool because it means if we can allow people to deploy new APIs with essentially zero risk. The resources are constrained. No one's accessing that API yet. So if you deploy something that like is absolute garbage, it'll just set on fire immediately, and no one cares. Like nothing happens at this point. And we're like super chill. So yeah, that's cool. So we have like change control processes that are like thorough, and we run automated tests and everything. But we can allow people to move really quickly because like there's essentially no downside to deploying a new API. Communicating between these things is a bit more complicated. So Kubernetes allows you to route between many copies of a pod. There are many things, I won't go through these. There are many things that you want to make your systems reliable. It only gives you the top 2, like basically service discovery and round-robin load balancing with no health checks, really. There's like readiness checks, but so we want lots of other stuff. So we use Linkerd, which the trendy term is a service mesh these days, apparently. It's a layer 7 proxy. Like it takes things, it proxies them. That's all it does. But it does it very well. So it will use the service discovery API basically from Kubernetes. It will monitor your services, and then if one of them fails, it'll just stop routing traffic there. So we route every request in our infrastructure through Linkerd, and it will manage these things automatically. For anyone who's interested in how that works in Kubernetes, we essentially proxy everything to a local daemon set, which actually you have to work out what the IP address is because we have like a subnet per physical host. But anyway, you can route all your requests there, and then Linkerd will send them on. And you can then see like interesting things where if one of the pods is really slow, it will receive fewer requests. So that's where like there's maybe something else on that machine that is quite noisy. So you see the number of requests received go down because the timings were higher, and Linkerd is routing traffic around that. And then we've got another one over here that you can kind of see happening. So the other thing that we make heavy use of to make our infrastructure more reliable and requests more reliable is by deferring work as much as possible onto queues. So there's kind of like an immediate path that if you open your app, you need a request to do something. But if we can split those things apart and publish events that things have happened, we can allow like pub submodels where we deploy new services without having to change the upstreams. If one service is broken, that doesn't affect people's behavior. And we can queue messages until those things recover. So those kind of things have made our systems a lot more secure, a lot more reliable. As far as security goes, that's fairly straightforward. We use an application load balancer. We also use some NLBs and ELBs, which allows you can use AWS Shield and the web application firewall. So if we see something particularly sketchy, either AWS Shield will automatically block that, or we can block it, and we kind of secure our stuff that way. We also directly connect to MasterCard and Faster Payments and a number of other payment schemes. So in that case, we have a set of services that are processing this. Connecting that is really hard. They give you fiber. You can't put a fiber into a cloud. Like, there's nowhere to plug it. So we go to data centers and like sit on the floor and plug that. That cable goes into the Faster Payment Network. So this is me like doing connectivity testing on my laptop. So the problem there is when you go through that process as a regulated industry, as a regulated company, you will have to provide assurances to the various payment schemes that you are complying with all of their regulations. That is a problem if you are working in a cloud, which is non-traditional, because a lot of those questionnaires are, where is your physical firewall box? Like, that's not how it works. We've got like a VPC and like, there's network segregation, there are ACLs and security groups, and they're like, but like the box, where is it? Like, can we touch it? No. So working with like auditors and regulators to identify where those problems are is something that was interesting for us. But ultimately, you can secure that. And then you can use various other things to secure your other infrastructure. So using like IAM roles, auditing with CloudTrail, basically to make sure that either people aren't getting into your infrastructure or your engineers and developers who do have privileged access in some cases are okay with that. So to kind of sum up, this is like a random trace that I've literally just found in our staging environment. Things like this are quite complicated, but the reason that we do this is because each one of these steps is very simple. So we can use tools to understand how the complexity works, but the complexity is not something that an engineer has to deal with on a day-to-day basis. If I see one of these things is broken, there's actually an error here, I can go to a service that is relatively small in Go, I can read the code, I didn't write it, I can understand how it works, and I can debug that problem very quickly. So even though there are like 700 moving parts, each one of those is really simple, so understanding that is really easy. So to kind of sum up why we do these things, we have a blog post which we published quite recently about the kind of engineering principles we have at Monzo. There's lots of things on there, but like I think the main ones for kind of this discussion are kind of building things quickly and shipping them to customers so you understand what their problems are is the most important thing. And working out the right thing to ship is hard. So doing it quickly and just iterating on it is super important. By making those changes really small and often, the risk is much reduced. So we don't have a 6-month deployment cycle. Some days we've deployed to production 100 times a day. And by leveraging like technical debt, as an expanding startup, if I choose not to do something today, in like 6 months, we might have 3 engineers who could do that thing. So actually, it's a lot cheaper and easier for us as opportunity cost. API Gateway lets us do that. Releasing features through Monzo Labs allows people to opt in. We also use experiments and multivariate testing. Production load testing and chaos testing is super important. So this is a production load test compared to our baseline. We also have shadow traffic, which allows us to multiply our API traffic by like many orders of magnitude. So we can test our like auto scaling actually works. And to go back to like the original things, we've built an extensible system that scales really quickly. We can deploy things really, really quickly and add new features quickly in the space of days, sometimes a day. It's comparatively cheap because we've boxed everything in and we make very efficient usage of our resources. And running in Amazon is a lot more secure than we could ever hope to achieve as a small company if we were like, there's a data center about 2 streets over here. Like, there's no way that data center will be as secure as an Amazon facility. So those things I think we have achieved. And yeah, by kind of building them small and simple, with no single points of failure, and by minimizing the critical path, we can make our systems a lot more reliable. Yeah, if that's interesting to you, come and talk to me. Do we have time for questions? Like 1 minute over.
Wow.